This is the video for mixture problems. This is section 2.8. And for mixture problems, are problems that are two or more parts are combined into a whole. Delectable Cookie Company sells chocolate chip cookies for $6.95. So on here on your matrix, what you're going to do is put the price per pound at $6.95. And sugar cookies for $5.95. How many pounds of chocolate chip? So we need to know that this is the variable, since that's your question, is how many pounds of chocolate chip. That means that the W goes right here. The number of pounds of chocolate chip will represent the W. And should be mixed with 4 pounds, so 4 pounds of sugar cookies to combine a mixture that sells at $6.75. So to combine the mixture, you need to put the chocolate chip cookie mix and the sugar cookie mix together. How do you get the total prices? You're going to multiply them. That's W times 6.95. 4 times 5.95. And a W plus 4 times 6.75. To solve the problem, what we're going to do is set the equation P times 6.95 plus 4 times 5.95, and that's equal to, so these two parts equal together should give you the mixture of W plus 4 times 6.75. We're going to go ahead and do the multiplication. We got 6.95 P plus, and then 4 times 5.95 becomes 23.8. And that's equal to, and then we're going to do the distributive property. That means 6 times W is going to give you 6.75 W plus. And then 4 times 6.75 is 27. I'm going to subtract that 6.75 W from both sides. 6.75 W, sorry, and I put a P over here. I'm sorry, that's supposed to be a W. And the reason that I noticed is because my letters wouldn't line up. And then I'm going to subtract the 23.8 from this side, minus 23.8. I'm left with 0.2 P is equal to 3.2. Then divide by 0.2 to both sides. I'm not sure why I keep doing that. Sorry, W. W is equal to 16. That means that W is equal to 16 pounds of chocolate chip cookies should be mixed with 4 pounds of sugar cookies to get that mixture. Okay, so the next one I have set up, and it's the first problem. We're going to do the grocery store has 2 kinds of candy. Sugar candy sells for $1.55 per pound, so the price per pound at $1.55. And the sugar-free candy sells for $2.95 per pound. How many pounds of sugar-free? So that's where I got my W. The number of pounds of sugar-free candy, W, should be added to 15 pounds of sugar candy. So right here's the 15 pounds of sugar candy. To make a mixture that sells for $1.75, so put these two together, that's 15 plus W. We multiply the sides out, and then together it's supposed to equal to this. So 15 times 1.5 gives you that 23.25. W times 2.95, we just rewrite as 2.95 W. Then we do the distributed property. That's 15 times 1.75 gives you 26.25, and 1.75 times W is the negative 1.5 W. From here, I eliminate this from this side, and that means I have to subtract 23.25 from both sides. And then I eliminate that 1.75 W. That means I have to subtract it from both sides. I'm left with 1.2 W is equal to 3. And then you divide by 1.2. That means that 2.3 pounds of sugar-free candy need to be added to the mixture to get you the price of $1.75 per pound. Okay, then number 2, I'm gonna help you fill it in. It says you want to make a Halloween party mix. So this is a party mix with popcorn and pretzels. So we're gonna put popcorn here and pretzels here. To sell for a fundraiser, popcorn costs $1.10 per pound. So this is price per pound. And the popcorn sells at $1.10. And the pretzels cost $1.49 per pound. How many pounds of popcorn? So X will be the number of popcorn. That means that this will be our X. And that means that this title is the number of pounds. Must be added to 4 pounds of pretzels, so 4 pounds of pretzels to get our mixture. We're gonna add those two together. And it has to sell for $1.25. And then on here, we got our total price. We gotta multiply these things. X times 1.10. 4 times 1.49, and X plus 4 times 1.25. That means our equation is going to be set up as 1.1x, that means the same thing, plus, and I'm going to go ahead and multiply these out. 4 times 1.49, it's 5.96. 5.96 is equal to, and we got to multiply this to the x, gives you 1.25x, and then 4 times 125. Oops, we'll clear that. 4 times 1.25 is equal to 5. We're going to subtract 1.25 from this side to cancel it out here. We're going to subtract 5.96 from both sides to cancel it out here. 1.1 minus 1.25 is equal to a negative 0.15x. 5 minus 5.96 is equal to a negative 0.96. Divide by negative 0.15 of both sides. X is equal to, so divided by a negative 0.15, 6.4. That means that we need 6.4 pounds of popcorn to be added to our mixture of 4 pounds of pretzels. number 3. Uh, a nursery sells Kentucky bluegrass seeds for, so we're talking about seeds. We got a Kentucky bluegrass, and so we know we have to deal with number of pounds. This is price per pound. And this one equals $5.75, and total price is what we're gonna have to fill in later. And then tall grass seeds for $4.50. Fescue. The nursery sells a mixture of the 2 kinds of seeds for $5.25, so that's your mixture. Let K represent the amount of Kentucky blue, so this would be K. And the nursery uses 5 pounds of the mixture. Uses 5 pounds of the mixture. So we need to figure out how much of this, the tall grass that they need, but we know that 5 is the total, so we're going to do 5 minus K this time to get the rest. So 5 minus the Kentucky would give you what's left of the tall grass. We multiply this out, we have 5.75 K. I'm going to write it as 5 minus K times 4.5, and then 5 times 5.25 is equal to 26.25. So remember, we still have the same formula, that 5.75K plus the 5 minus K times 4.5 is equal to the 26.25. Sorry, we don't need a parentheses here. We're going to do the distributive property. That's 5 times 4.5. And that gives me 22.5. Then minus 4.5K, because a negative times a positive makes a negative 4.5K. We'll rewrite the rest. We're going to combine like terms. That means I'm going to do this one minus this one. 5.75 minus 4.5 equals a 1.25K plus 22.5 is equal to 26.25. We're going to subtract the 22.5 from both sides. 1.25 is equal to 26.5 minus 22.5 is 3.75. And I forgot my letters, sorry about that. There's the K. So now we divide by 1.25. K is equal to 3. That means that there has to be 3 pounds of the Kentucky bluegrass. Well, that kind of makes sense, right? If we know that, well, if we do this one 3, then 5 minus 3 is 2 for the tall grass. All right, so then these mixture problems with percent, we have Olivia's trying to make her favorite lemonade. The lemonade she buys at the store contains 20% lemon juice. So we're gonna do lemonade. And I'm gonna call it the store bought one. And what we have is percent of juice. Percent juice from the store-bought one is 20%, but we don't write 20%. Remember, we move it over 1, 2. 0.2 is how we write that. And then total juice is what we're looking at for this one. And right now we're going to go in ounces, number of ounces. Olivia wants to add pure lemon juice to the 20% blend to make 16 ounces of her own blend. So we know we're going to have ounces, 16 ounces. That's 16 of her mixture. And so what's the other juice? That contains 30%, so remember we're moving it over twice, so that would be 0.3 of lemon juice. Let J represent the number of lemon juice. So we got lemon juice right here. And J is the amount of lemon juice. So we're going to call it pure, so it's pure lemon juice. J represents the amount, so we don't know how much there is, and we're calling it J. Well, how much is 100% pure lemon juice? It's 100%, so instead of writing 100%, remember we move the decimal over and you get 1.00. So how much is the store-bought kind? Well, we're going to take the 16 ounces total that we have, 16, and we're going to subtract the lemon juice from it, and that's what's left for the store-bought kind. Remember to put these together, we got 0.2 times 16 minus J. J times 1, which is 1J. We don't really need to write the 1. And then 16 times 0.3. I'm going to go ahead and leave the 0.2 of the juice is 16 minus J plus the 1J, so I'm just going to call it J, is equal to, and then 16 times 0.3 is 4.8. Gonna do the distributive property, that's 0.2 times 16 is 3.2, and then 0.2 times a negative J is a negative 0.2J plus J is equal to 4.8. Now we're gonna combine like terms, that's this plus this, or negative 2 or negative 0.2 plus 1, because it's 0.1, 1J. That's 3.2 plus 0.8J, because it turned out to be positive 4.8. Now we're going to subtract the 3.2 from both sides. 0.8J is equal to 1.6 divided by 0.8. And it's equal to 2. Then there's 2 ounces of pure lemon juice that's going to be added. Number 5. Nathan is trying to make a very sweet tea, sweet coffee drink for his dad. How many grams of sugar? So we're looking at the drink. It's gonna have the coffee mix. So iced coffee. And it's going to have sugar added to give you the mixture. So since we're talking about grams, we need the number of grams. And percent of sugar. And that's going to give us the total sugar. Okay, so how many grams of sugar must be added? So we're adding sugar, and that's the G. And how much of percent of sugar? Sugar is 100%, which remember we write as 1 because we're 100%. We move the decimal over to write it as a decimal. Must be added to 50 grams of iced coffee that is 30% sugar. So don't forget to move the decimal over to obtain the mixture that is 70%. Oops, and I forgot to move that decimal over of sugar. So we're going to add these two together, the 50 plus the G, to get the mixture. And now we have 50 times 0.3, G times 1, and then 50 plus G times 0.7. Okay, so we're going to do 50 times 0.3 is 15. 15 plus 1G is just G. And then on this other side, we have 0.7 times 50. And it's 35. And then 0.7 times G is 0.7 G. I'm going to subtract the 35 from this side. And I'm going to subtract the G from this side. Have 20 is equal to 0.3 G. Divide by 0.3 to both sides. And that's negative, and that would be negative divided by negatives. That's 66.7 grams of sugar. Well, it's 70%, remember, we wanted 70% of sugar. So we're going to have to add 66.7 grams of sugar to that iced coffee. Okay, and our last one is how many grams of sugar must be added to 60 grams. So we got a solution. Oh, and on here I forgot to mention that this is the number of grams of sugar. How many grams of sugar? So again, we have the number of grams of sugar. So we got sugar, number of grams, and we don't know, so we're calling it G. And then percent of sugar, and then total sugar. What percent of sugar is sugar? 100%, so we just call it 1.00. And must be added to 60 grams, so we got 60 grams of the solution. That is 32, so 0.32% of sugar to obtain a solution of 50% sugar. So we're going to add those two things together to get a mixture. Multiply these numbers together. 1 times G is just G. 60 times 0.32 is 19.2. And then I'm going to leave this as G plus 60 times 0.5. So we add these two together. G plus 19.2 is equal to G plus 60 times 0.5. Going to distribute out that 0.5. G plus 19.2 is equal to 0.5 G plus 16 times 0.5 is 30. We're going to subtract that 0.5 G, subtract that 0.5 G, and subtract the 19.2, subtract the 19.2. This would be a 0.5 G is equal to 10.8 divided by 0.5. Grams is equal to 21.6. So they need to add a total of 21.6 grams to the solution of sugar.